Good morning, students. So I'll continue with the next topic, computer types. So previous class have explained you about the computer definition and computer generations. Today, I'll talk about computer types. Having discussed about the definition of a computer and computer generations. Okay. Today we'll continue with the computer types, different types of computers available. Okay. So computer today we'll talk about computer types, and along with that, I'll also talk about bytes, and words. Okay, let's talk about computer types first. Computers can also be categorized by their size. The size of a computer is often an indirect indicator of its capabilities and the application domains they are employed. Because of constant changing technology, there would be some overlap here. Today's mainframe could be tomorrow's mini computer. We present these categories in order of descending size. Okay, so I'll talk about the computers, starting from supercomputers to today's laptops and palm toms. The size will going to be decreased uh, as we and discuss about the computer types. Okay, the different types of computers are based on about their size and their speed, cost, uh, okay, and many more. Types of computers, you can see a diagram being given in the bottom of the slide. Look at the size and speed. The size and speed, size and speed, size and speed. Microcomputer, as far as the size is concerned, microcomputer is smaller than mini. Mini is smaller than mainframe, and mainframe is smaller than supercomputer. Speed increases as we go from microcomputer to supercomputer. Size increases and speed also increases. We know the capability of a supercomputer. Supercomputer having many multiple cores of CPU. It's definitely having a higher size and higher speed compared to micro and mini computers. Uh, okay, so one more important aspect what I want to discuss with you is, after 2004, Intel Corporation thought that if there is any improvement to be made, the improvement is not with the single computer. Okay, if you want to improve the performance of your machine, then go for multiple cores. Uh, Probably you have heard of the names dual core, quad core, octa core. Okay, dual means two, quad means four, octa means eight. Today's computers are having more than one CPU. Okay, so each CPU, within the CPU, you can have multiple cores. Each core is capable of processing its own set of instructions. Okay, so parallelly, you can able to process your programs, execute your programs. You can get the service. You can get multiple services, in fact, from each core separately. You can have these services with the advent of technology. Fine. Let's begin with supercomputers. Supercomputers are huge machines having the most powerful and fastest processors. Uh, they are the huge machines because since they have many central processing units, multiple uh, uh, a supercomputer uses multiple CPUs. multiple central processing units for parallel data processing. Each CPU is capable of processing its own set of instructions, its own set of programs, which means portions of the same program are handled independently by multiple processors. I mean, you can able to process the data parallelly. You can either have a separate program given to each CPU, or multiple CPUs will going to handle one big program. They will partition the work. Okay, they will partition the task to be completed. Fine. Speeds of supercomputers are measured in flops, floating point operations per second. Okay, the speeds of different computers are measured differently. As far as supercomputers are concerned, speeds are measured in floating point operations per second. The fastest supercomputer, the Tianhe 2, operates at a speed of 34 petaflops. 1 peta is equal to 1000, tera is equal to, look at the number, 10 lakh giga. Supercomputers can enable to handle multiple users, but that's not its unique feature. Those supercomputers can able to serve different clients request at the same time. That's not its unique feature. Supercomputers are built for huge calculations. Normally, supercomputers are too powerful to be used for transaction processing. Transaction is the word normally used for calculations. In banking operations, normally you have heard of this word. Supercomputers are too small. They are very huge. They are they are very big to be used for transaction processing. For normal transaction processing, our normal machines, micro and mini computers can be used. The supercomputers, they are employed in areas that require enormous number of crunching, like weather forecasting, analysis of geological data, nuclear simulation, and space exploration, space related aspects, astronomy, astrological calculations, space related, uh, we know our earth and its surrounding, its nearby planets. We normally calculate the distances in light years, that we know. To calculate such data, and the data and the calculations related to such data cannot be done using our mini and microcomputers. Definitely supercomputers must be employed for calculating the data related to such aspects. Supercomputers have enormous storage, huge amounts of power, and generate a lot of heat. Storage capacity is definitely big, because having done enormous calculation, we must have enormous storage for storage purpose. Uh, Use huge amounts of power, and at the same time, when power investment is more, generally they generate a lot of heat. That is for sure. Mm. And here in supercomputers, in one of the line, we have used peta and giga. I'll talk about those words. What is a bit? What is a byte? What is a megabyte? What is kilobyte? I'll talk about these words in the next upcoming slides. Okay, next, after supercomputers, next one is the mainframes. Before the advent of supercomputers, mainframe computers were the largest computers available. Okay, before the invention of supercomputers, we had mainframe computers. Okay, mainframes were the largest computers before supercomputers. These are multi-user machines that can support hundreds or thousands of users, using the feature of time sharing supported by systems like Linux. In the previous class, I have discussed the concept called by the name time sharing. CPU time is shared across multiple users. That was the concept supported by systems like Linux. Linux is an operating system, and mainframes are capable of supporting thousands, thousands of users at the same time. Users can interact with the system using a terminal and keyboard, which is akin to the way we use PCs. I mean, though it supports hundreds or thousands of users at the same time, each user can able to interact with the machine. Each user thinks that the entire machine is dedicated to him or her, though it is shared across multiple users. Each user thinks that the entire machine is dedicated to him or her. It happens because the switching between the users is so fast that it gives an illusion to each user that the entire machine is dedicated to only to him or her, though it is shared across thousands of users. Mainframes can concurrently run multiple programs even with a single piece CPU. Okay, they can concurrently. Concurrency means at the same simultaneously. Okay, at the same time, at any given point of time, they are capable of uh, uh, serving multiple users. They're capable of running multiple programs with a single CPU. Single CPU, can always be equated with one person. We know one person can do only one work at a time. Okay, one CPU can be equated to one machine, though we can do multiple works at any given point of time. But though we can do multiple works at any given point of time, we can able to concentrate only about one work. Okay, if we keep multiple files, let us say I'm keeping 5 files in front of me. Though I am capable of looking at the files parallelly, I can able to look into one file at any given point of time. Same thing, switching, control jumps from one program to another program. Okay, single CPU, it's if there are multiple CPUs, of course, each CPU can be dedicated to one user. If there is single CPU's time must be shared between different users. That's the difference. Multi-user machines. There is a difference between multiple CPUs and a single CPU. Multiple CPUs means if there are more than one, if there's more than one CPU, let us say there are two CPUs. So each CPU can be dedicated to one separate user. In that way, they can serve two different users. If there is single CPU, still we can serve two or three or four or any number of requests can be served. But here, using single CPU, we have to share its time across different users. The processor speed in a mainframe is measured in MIPS, millions of instructions per second. Okay, what was the term we used with the supercomputers? Flop. Look at the word, floating point operations per second. Speed of a supercomputer is measured in floating point operations per second, whereas the speed of a mainframe, it's measured in millions of instructions per second. Mainframes are generally used to handle data and applications related to the organization as a whole. You can service the entire organization. They are capable of handling data and applications related to an organization. Today, mainframes are employed to handle online transactions, transactions like you have seen in news or in newspapers, like stock exchange transactions, for instance. The capability to handle large amounts of data makes the mainframe suitable for use in government, banks, and financial institutions and large corporations. Okay, so such machines can be used in governments. The machines can be used in banking for transaction purpose. The machines can be used in financial institutions. For example, KSFC, Karnataka State Financial Corporation, and any other large corporation related to calculations, banking, or providing services to the end users. Okay, next set of machines are called by the name mini computers. The mini computer, which Digital Equipment Corporation, DEC, introduced in 1970s, is thus rightly positioned between mainframe and a microcomputer. Its size, probably its usage, its position. Because of these facts, its position between mainframe and a microcomputer. Mainframe was discussed in the previous slide, and microcomputer is going to be discussed in the next slide. It can be positioned between mainframe computer and microcomputer. Okay, mini computer can be considered as downsized mainframes since they have the essential features of mainframes. Mini computers can serve hundreds of users and are small enough to partially occupy a room. Okay, but they are not affordable enough to be used in the home. Mini computers are used in small organizations or a department of a large one. Unlike uh, mainframe computers, these computers cannot be used for large calculations. Look at the word. They are used in small organizations or a department of a large one. They are also used as captive machines of tank equipment running specialized software. It is now possible to connect several microcomputers in a network where one computer doesn't need to have all the processing power. Okay. Next, microcomputers. Microcomputer or personal computer, PC, is a late entrant to the computer family. Okay. Introduced by Apple and later endorsed by IBM. This computer is a single user machine powered by a single chip microprocessor. Single user machine. Okay. It's powered by single chip microprocessor. Today's personal computers are very powerful machines having gigabytes of memory and a terabyte or two of disk storage. I mean, they are used both in standalone mode. I mean, at home and in a network. I mean, in office. A microcomputer takes the form of desktop. Probably you have seen in your homes desktop computers, notebook, or a laptop or a netbook, smaller laptop. Okay, laptop. It looks like a notebook or a bigger notebook, and a netbook. Okay, notebook and a netbook. Netbook, it's a smaller laptop. Each core, as I told, dual core, uh, quad core, octa core, and dual means two cores. Within a CPU, there are two processing cores. Each core is capable of handling one separate program or one different set of instructions. Each core can be considered with some approximation as a processor by itself. Each core can roughly be considered as a processor. Earlier to 2004, okay, there was only one CPU, only one processor within the system. Now, after 2004, normally in today's computers, they're having more than one. I mean, they come with cores. If there are two cores, each core can be considered as a separate processor almost. PCs today are powered by three types of operating system. I mean, the operating systems used across different machines are different. I mean, you have seen Windows. Windows in that now probably your generations seen Windows 7, Windows 8, Windows 10. In my system, I'm using Windows 10. The operating system can also be Mac OS X, Apple, and Linux. In the previous class, I've explained in within Linux. There are different flavors like Ubuntu, Red Hat, SUSE, okay, Fedora, okay, etc. A variant of the microcomputer is the workstation, which essentially is a microcomputer with a more powerful processor, a high resolution terminal, and high quality graphic capabilities. Workstations are usually connected in a network for sharing of its resources. The reason why some of them are also diskless. Okay, so this is about microcomputers. Let us talk about smartphones and embedded computers. Okay, the relentless drive toward miniaturization has led to the emergence of two types of devices called smartphones and embedded computers. I mean, always we look into the optimization. I mean, we always try to minimize the size, we minimize the cost, we want to increase the speed. These capability, these words are very, very important related to the devices, especially smartphones and embedded computers. Smartphone, I don't have to explain about a smartphone. Probably you are watching this meetings conversation in a smartphone or in an embedded computer. Okay, smartphone you can do many not only used for just calling purpose. You can watch videos, you can play games, online games, you can look into the internet. You can have data installed into it. You can do many more things. The smartphone, it's an important device that too during this period, an epidemic period. Okay, smartphone is a essential gadget. The smartphone is a general purpose computer that is also capable of making phone calls. The smartphone has a powerful processor. Okay, smartphone definitely it's having a processor, usually with multiple, as I mentioned, quad, dual core, quad core, octa core. It also supports gigabytes of memory, but doesn't have a hard disk for storage, secondary storage. A smartphone has a keyboard and a high resolution display. Okay, you can have a keyboard or a touch screen having okay. I mean, for typing purpose, both operated by touch or a style. These are very small circuits containing a CPU, non-volatile memory, and input-output handling facilities. Okay, CPU. I have discussed about this word CPU, Central Processing Unit, non-volatile memory, volatile memory, and non-volatile memory. I'll talk about this word in the later part of first module. Input output handling facilities, input and output. I mean, you can able to give the input to the smartphone. You can expect output, you can see videos, you can play games, you can touch the screen to get the work done, you can do calculations, you can do many more things. The embedded computer is a small computer like system that is part of a larger system. They are embedded into many of the machines that we use in cars, washing machines, MP3 players, and cameras. Okay, so don't think that the microprocessors are the CPUs are used only in computers. They're used in almost all parts of our day-to-day life. I mean, today world has become like one of the important research area here today is the Internet of Things. I mean, we'll all the equipments are embedded with microprocessors and internet, cars, washing machines, MP3 players, cameras. Okay, cameras they have a small CPU core. They're capable of doing. I mean, you can store the pictures, you can store videos, you can send the captured videos and photos to your friends, family, and they can be used for processing further. You can do many more things. Okay, the processor here runs a single unmodifiable program stored in memory. Embedded computers can't match the capabilities of a smartphone. Okay, but they don't need to because the processor is dedicated to a specific task. its capabilities are just adequate to operate the device. Okay, so the word, I can just only say that the word has become ubiquitous. The word, I mean, everything, it's computer, it's processor based, all the equipments, all the machines. So types of computers, have discussed different types of computers, starting from supercomputers to today's smartphones and embedded computers. Let us talk about one more important topic today. Uh, that's called by the name bits, bytes, and words. In everyday life, we use the decimal system for computing, where a digit can have 10 values or states. However, in the first class, have discussed about two states, 0 or 1. Okay, you can say on and off. You have seen these, you have heard of these words in from your plus 2, I mean from your PUC or whatever. So 0 and 1, you can say on and off, and are true or false. Okay, uh, 0 or 1. A digit that can have only two states or values is known as a binary digit, abbreviated as bit, 1 bit. Okay, a computer is capable of understanding only 1 bit, either 0 or 1. All binary numbers are represented by combining these zeros and ones. Okay, the byte is the standard unit of measurement of computer memory, data storage, and transmission speed. A DVD-ROM has a capacity of 4.7 gigabytes, 4 into 109 bytes, and internet speeds of 4 megabits per second are common. Okay, so I'll talk about, so 1 bit means either it's a 0 or 1. Uh, Let us further talk about these words. Look at the relationships between these units are expressed in the following manner. 1 bit, I again repeat, 1 bit means it's either 0 or 1. Next, a group of 4 bits, it's called nibble, Nibble. A group of 8 bits, it's called by the name byte. Group of 8 bits, either 0 or 1. It can be any combination, all 8 zeros or all 8 ones, or 0 1 0 1 0 1 0 1, any combination. A group of 8 bits, it's called 1 byte. Group of 4 bits, it's called nibble. A single bit is either 0 or 1. Then 1 KB, look at capital letter KB, 1 kilobyte. 1 kilobyte means 1 byte is 8 bits. 1 KB, 1 kilobyte is 1024 bytes. Space used by 10 lines of text. Example, for example is also given under remarks section. Okay, roughly it's the space used by 10 lines of our text. It's 1 KB, just 1 KB of text. Okay, then after KB comes MB, megabyte. Okay, 1024 kilobytes. 1024 kilobytes. I mean, 1 kilobyte is equal to 1024 bytes. 1 megabyte is equal to 1 into 1024 into 1024. Okay, bytes. As far as bytes are concerned, 1 kilobyte is equal to 1024 bytes. 1 megabyte is equal to 1 into 1024 into 1024 bytes. It's 1024 kilobytes. Memory of the earliest PCs, memory of our beginning computers. Okay, it was roughly 1 megabyte. Uh, the memory of my first computer was just 64 MB. Okay, 1 gigabyte. 1 gigabyte is equal to 1024 into 1024 into 1024 bytes. I mean, it's equal to 1024 megabytes. Okay, storage capacity of a CD-ROM. Okay, 1 GB. 1 GB. Roughly, CD-ROM it's having 750 MB or roughly 1 GB. DVDs specifically having more. I mean, DVDs capacity is around 4 to 5 GB, whereas capacity of CD-ROM is roughly 1 GB. As an example, it's given under the remark section. 1 terabyte. Okay, 1 terabyte is equal to 1024 gigabytes. Capacity of today's hard disk. The capacity of I have purchased an external hard disk. Its capacity is equal to 1 terabyte. It's minimum probably. You don't get hard disks today lesser than that size. 1 terabyte, which is equal to 1024 gigabytes. 1 petabyte is equal to 1024 terabytes. It's the space used for rendering film like Avatar. I hope you have seen the 3D film Avatar. The space used for rendering of the film called Avatar, it's roughly equal to 1 petabyte. 1 petabyte is equal to 1024 terabytes. Look at the sizes: 1 kilobyte, 1 megabyte, 1 gigabyte, 1 terabyte, 1 petabyte. The size increases. The size increases. If it is only text, if you are handling only textual data, then the size is normally very less. It's measured in kilobytes. That's why if it is just one page of text, it's normally kilobyte. Memory of earlier computers, as an example, it's given for megabyte. 1 gigabyte is equal to 1024 megabytes. 1 terabyte is equal to 1024 gigabytes, and 1 petabyte is equal to 1024 terabytes. That's the space used for rendering films like Avatar. It's been mentioned here. So starting bit, bytes, and words. 1 bit is equal to 0 or 1. 1 nibble is equal to a group of 4 bits. 1 byte is equal to a group of 8 bits. Then 1024 bytes is equal to 1 kilobyte. 1024 kilobytes is equal to 1 megabyte. 1024 megabyte is equal to 1 gigabyte. 1024 gigabytes is equal to 1 terabyte. 1024 terabytes is equal to 1 petabyte. Okay. Uh, a similar relationship exists for bits as well as, or for that matter, any quantity. So the speed of a network expressed in 1 Mbps. I hope you have heard of the name 1 Mbps, 1 megabits per second. 1 Mbps means 1 megabits per second, the speed of a network. I mean, you can download probably the data, which is roughly 1 megabit, or the data, what is coming into your machine or your device, it's 1 megabits per second. Network speed, it's normally measured in 1 megabits per second, or 100 kbps, or sorry, here it's mentioned as 1000 kbps, 1000 kilobits per second. The data what's entering your device or your machine, it's let us say it is equal to 1000 kilobits per second. Okay, it is customary to use B. Look at the word, don't get confused between capital B and small b. capital b capital B means bytes. Okay, byte we know it's a group of 8 bits, and small b, it's used to signify bits. Thus 1 KB, capital letter K, capital letter B signifies 1000 bytes, but 1 K, capital letter K, small letter B is the same as 1000 bits. Okay, 1 KB, capital letter K, capital letter B, it signifies 1000 bytes. 1 KB, capital letter K, small letter B signifies 1000 bits anta. 1000 bytes and 1000 bits. So you need to have in your mind the difference between capital letter B and small letter b. Okay, to differentiate between bytes and bits. Okay, you will need to look at, for example, in the second line, look at 1 Mbps. Small letter b is used. 1 megabits per second. Okay, 1 megabits per second. Most machine instructions are one word in size. I have discussed till now, I have discussed about what is a bit, what is a nibble, what is a byte, okay, what is 1 kilobyte, what is 1 megabyte, what is 1 gigabyte, what is 1 terabyte, and what is 1 petabyte. Now, let us talk about one more important aspect called by the name word. Most machine instructions are just one word in size. And because a CPU register must be able to hold an instruction, it too is one word wide. In the beginning, in the first class, in the first lecture, I have used the word register. Registers are part of the CPU. Okay. Then bigger than register comes cache memory. Then bigger than cache memory is the main memory. Then bigger than the main memory is the hard disk. Okay. Registers, you cannot keep all the instructions and data inside the registers because the registers are very few in number and each register is capable of holding one word of data. What is one word? I'll talk about it. Okay, so when we refer to a computer as a 32-bit machine, we mean the size of its word is 32 bits. Okay, word size depends on the host machine. I mean, if a machine, if a computer, let us say if it is a 32-bit machine, it means 32. Okay, 32 means how many bytes? 4 bytes. 32 bits, because a byte is a group of 8 bits. 32 bits means 4 bytes. If I say a machine is a 32-bit machine, I mean the size of a word is 32-bit. If it is a 16-bit machine, the size of a word is normally 16 bits. If it is a 32-bit machine, the size of a word is 32 bits. Okay. Memory is measured in kilobytes, megabytes, gigabytes, and terabytes. Okay. Each unit is 1024 times as big as its immediate predecessor. For example, 1 GB is equal to 1024 MB. For reasons of convenience, we often use 1000 as the multiplier instead of 1024. Okay. So one more important thing is 1K. K means 1000. Here 1000 is not exactly is equal to 1000. 1K ಅಂತಂದ್ರೆ here it's equal to 1024 because memory is always in terms of powers of 2. Okay, what is 2 to the power of 0? Anything to the power of 0. A to the power of 0 mathematically is equal to 1. Okay, 2 to the power of 0 is equal to 1. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 4. So anything, its memory is in terms of 2 powers. I mean, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8172, 16,000 something, then 32,000 something. Okay, memory is always in terms of powers of 2. Uh, and memories, though each location in memory, if I'm using the word memory, and in the previous class itself, in the first class itself, I have made it very clear. If I am using the word memory alone, it means that I'm talking about primary memory, RAM, random access memory. Okay, so memory, in memory, each location, the size of each location is one word. I mean, though it is one word, memory is byte addressable. Okay, byte addressable. We locate each location in memory with the help of a byte. Memory is byte addressable. Okay, if it is a 32-bit machine, the size of the word is 32 bits. I mean 4 bytes. 4 bytes constitute one word. Though the length of one word is 4 bytes, but memory is byte addressable. In case of 64-bit machine, uh, each word constitutes 8 bytes. Though each word is equal to 8 bytes, still memory is byte addressable. Okay, so it all depends on the length of each word. Yeah, 16-bit machine, 32-bit machine, 64-bit machine. The length in case of 32-bit machine, uh, the length of each word is 4 bytes. If you are computer science students, you'll going to learn about one more subject called by the name computer organization in third semester. There you'll learn about bits, bytes, and words. Particularly in the whole textbook, they will talk about 32-bit machines. Keeping 32-bit machine as an example, all the topics have been covered. Okay. Uh, these aspects are very, very important. Okay, bit, byte, and words. So keeping these basics in mind, we will learn our future concepts again. Okay, we'll learn our future concepts. And in today's class we have discussed. Okay, we have discussed what we have discussed. I'll go through it once. Have discussed the types of computers, the size and speed, both increases. Starting if you go from microcomputer towards supercomputers, I mean the size and speed increases from microcomputer to mini computer, and from mini computer to mainframe computer, and from mainframe computer to supercomputer. Both size and speed decreases as you come down from supercomputer to mainframe computer, and from mainframe computer to mini computer, and from mini computer to microcomputer. So different types of computers have been discussed. Supercomputers are the huge machines having multiple CPU cores. Their speed is measured in floating point operations per second. Okay. The they are used for huge calculations in weather forecasting. Okay, uh, weather. Okay, cyclone predictions, weather. Okay, such calculations use supercomputers are used for such calculations. Analysis of geological data. Okay, area-wise analysis. I mean, what is the condition, geological conditions, nuclear simulation, space exploration. Okay, and mainframe computers uh, were the advent of were used before supercomputers. They are multi-user machines. They can support hundreds or thousands of users. Users interact with the system using a terminal and keyboard. Okay, mainframes can concurrently run multiple programs even with a single CPU. Then came mini computers. They were used during 1970s. Mini computer can be considered as downsized mainframes. Many computers are used in small organizations. Unlike mainframes, they are also used as captive machines. It's now possible to connect several microcomputers in a network where one computer doesn't need to have all the processing power. Then came microcomputers. Microcomputer or personal computer is a late entrant to the computer family, introduced by Apple and later by IBM. Okay, you can use these machines at home. Then came smartphones. Okay, smartphones uses different smartphones uses they have different vendors like Nokia, Samsung, different vendors and different operating systems. Different operating systems And then the smartphones are today not only used for making phone calls. And then have discussed bits, bytes, and words. Okay, what's a bit? It's either 0 or 1. What's a nibble? It's group of 4 bits. What's a byte? It's a group of 8 bits. Then I have also differentiated between 1 kilobyte, 1 megabyte, 1 gigabyte, 1 terabyte, and 1 petabyte. Okay, I've also discussed about these terminologies. Apart from these things, I've also discussed about a word length. In case of a 32-bit machine, it's 4 bytes. Okay, so today's class only 2 topics: computer types, bits, bytes, and words. Along with this recorded video, you'll also get notes and multiple choice questions. Please answer the multiple choice questions, and please refer the textbooks, both textbook and reference textbook. Okay, reference textbook. For computer concepts, you can use a separate textbook, and for programming later, you can use a different textbook. For computer concepts, you can use Sumitaba Das. Okay, for what's the computer generations, computer types. These aspects have been explained very clearly. Sumitaba Das textbook, it's one of the textbook mentioned in the references section. Please refer to it. And for that matter, you can also refer other textbooks. There are more than one textbook and more than one reference books mentioned in your syllabus for study purpose. And for concepts, you can also refer other good textbooks because there are a hell lot of computer books available. But for your syllabus, it's better. Please go through your syllabus. In the syllabus, it's mentioned. Okay, and as for your syllabus, what I have seen, Sumitaba Das in the Sumitaba Das textbook, in the first module, first half of the first module, it is meant for computer hardware and computer software basics. So please go through Sumitaba Das textbook, and it covers your first module, first half of the syllabus, and the second half of the first module. You can refer a separate textbook for that. Okay, so please go through it, and if you still have any doubts, you can call me, you can contact me anytime. And thank you for listening to me. Okay, we'll stop our conversation, and I'll continue with the next topic in the next class. Along with this recorded video, I repeat, you'll get some notes and multiple choice questions. Please make use of it. Please go through the notes and answer the multiple choice questions. Along with, please also refer the textbooks, both the reference textbooks and textbooks mentioned in your syllabus. You can also collect previous year question papers. I'll try to upload the question papers in VT website. Also, will get question papers, and please try to study from the beginning itself. And thank you for listening to me. We will continue with the next topic in the next hour. Thank you for listening. Okay. You can ask me the questions after seeing this recorded video. If you have any doubts, you can contact me anytime. Okay. So thank you.